Hello everyone, so my name is Tatiana Severin-Fabiani, working at Saint-Gobain.
Hello, I'm Yannick Sutter from Lumibien. Today we're going to tell you about our experiments to measure daylight autonomy and the way we try to assess the performance of the new daylighting EN 1737 daylighting standard with measurements. But before we do that, let me take you back to 2002 when I was a young PhD student. This is the setup of the field study I work on, and just having an illuminance measurements into these 8 offices, an illuminance measured every 5 minutes for 8 months, required 100 meters of wiring, lots of drilling from an electrician, and many hours of coding from a computer guy. And the whole setup of this field study took about 2 months. 16 years after, in 2018, last year, 20 sensors that measured illuminance every 5 minutes for 3 weeks are scattered into these 2 offices, and the setup of this field study took only 30 minutes. So how was this magic trick possible, Tatiana?
So Saint-Gobain R&D team has developed setup in order to measure the light in occupied spaces. The development was part of our R&D program on natural light and comfort, and has been internally used during quantitative diagnostic campaign in Saint-Gobain buildings. Here some past and future examples are cited here. So the setup is composed of 10 lux meter. It is easy to install setup because it is wireless. It is quite small, as you can see here. This is one of the sensor, and it is easily portable. So all the 10 lux meter are linked together by Bluetooth, and a Raspberry Pi collects continuously the data during the measurements. The lux meter are programmable for measurement time lapses also. And so in 2018, Saint-Gobain teamed up with Lumibien in order to set up the field study to test this Luxbox kit in offices.
Yes, so we set up a field study into 2 offices with 20 of these sensors measuring illuminance every 5 minutes for 3 weeks in October. So 7 sensors were located on each of the 7 workstations, as you can see on the drawings here. We had 2 objectives. The first one was to test the device on a long period of time, so 3 weeks. And the second objective was to compare illuminance statistics with individual assessments of lighting condition in the offices by the occupants. So we made several types of analysis, and we will just show the ones that we thought are the most relevant. And the first set of statistics that we found interesting was the median illuminance at each workstation for daylight and electric light combined. So median illuminance is the illuminance that is exceeded during 50% of the time at each workstation during 3 weeks. Only 5 workstations here you can see. That's because unfortunately 2 sensors failed to record for the whole period of measurement. And this seemed to us like an interesting way to assess the overall lighting quality in a space, since usually electric lighting and day lighting are assessed separately. So this is actually combined. So as you can see, there's quite a bit of information here, and a lot could be said about this data and the lighting quality in these 2 offices. But today we would like to focus on day lighting performance only.
Oops.
So this is the illuminance measurements. So again, every 5 minutes at each of the 7 workstations during a weekend in October. So this means no occupant, no electric light, just daylight. And as you can see, you can get up to 800 lux for the occupants that are close to the window. So I don't know if you can see, that's the 4 occupants up there, Marilène, Blandine, Émilie, Isabelle. They have illuminance up to 800 lux during those 2 days. And for the 3 people that are in the second half of the room, they never exceed 200 lux during these 2 days. So we calculated the median illuminance at each of those workstations, as well as the daylight autonomy to 300 lux during these 2 days. And no surprise, very poor results for the occupants that are far from the window. So for Lucienne, Iman and Marilyn, you can see that the daylight autonomy is 0. So now Tatiana will tell us about the conclusions of this first field study.
So during this campaign, we have tested the possibility of performing quantitative assessment of lighting quality in 2 offices, allowing to identify lighting issues for occupants. This quantitative assessment has been compared with the occupant perception using a questionnaire that has been developed by Saint-Gobain. So this questionnaire takes into account both quality and quantity of electrical and natural light. Here are the different elements that can be evaluated in this questionnaire, but focused on natural light. When we extract the ranking on natural light and we compare that to the measurement campaign, we can see a good coherence between the occupant perception and the measurement during this period. While additional information can be extracted from that. A lot could be said, but what we want to ask now is how to assess the new standard compliance with on-site measurements. And to try to answer that, we have organized a second measurement campaign during another period of time, in July this time, and it will be presented right now by Yannick.
So yes, so in July we decided to do a second measurement campaign in the same building. Just one office this time. In one office we put 10 of the illuminance sensors, and for every 5 minutes, again, for one weekend, so no occupant, no electric light, we measured the illuminance variation. So, and we wanted to check the compliance with the new daylighting standard. So as you can see on the right, these are the median illuminance values for each of the sensors. So again, this is the illuminance that is exceeded during 50% of the time. And this table here, you've seen it before, is the recommended values, illuminance thresholds for daylighting quantity in the new daylighting standard. And what we can say is that in this room, during these 2 days, 100% of the sensors have an illuminance that exceed the minimum target of 100 lux here. So all the sensors exceed 100 lux, and the threshold here in the standard is 95%, so we comply. We can see that 70% of the sensors exceed the target illuminance of 300 lux, so we comply with the minimum level. And the next question is, do we actually comply with the medium performance level? And we can see that 70% exceed 300, 70% of the sensors here exceed the recommended value of 300, and we want 95 in the standard, so we don't comply. So we won't achieve the minimum medium performance level, and we achieve the minimum. So for this weekend in July, this room complies with the minimum level of the daylighting standard. And of course, the question is how could we assess the annual performance with the standard using measurement on an annual basis? And is it actually possible? We came across 2 interesting methodologies. The first one, in the first one, we learned that when selecting a sample of only 5 days a month to do an annual climate-based daylight simulation, we get an error as small. We can get an error as small as 5% compared to the full 365 days simulation. So, obviously, we're wondering if we could apply this to a measurement campaign, and how much measured data would we actually need to be able to get a reasonably accurate conclusion, a result. And the second interesting methodology we came across is the lead daylighting credit. There is actually in the lead daylighting credit an option 3, which is a methodology to assess daylighting performance with measurement. So it says achieve illuminance levels between 300 and 3000 lux for the floor area indicated in table 3. So you can see those values, percentage of area in the table 3. And there is also table 4, which is quite interesting because it says that if you're doing your first set of measurement in one of these 12 months, you have to do a second set of measurements in this other part of the year. So we thought it was quite interesting, and we were wondering if this would mean actually that doing measurement at two opposite periods of the year would give us a decent idea of the annual overall daylighting performance of a space. That's a question we were wondering. And we did some simulation to test this hypothesis.
So to test this hypothesis, and in order to design an experimental protocol that can be applied on the measurement, we start with simulations. Because we can access to annual performance and especially the daylight autonomy, the annual daylight autonomy of the room. So first we designed the office and we extracted from that the daylight autonomy of the space. This daylight autonomy could be compared to the standard recommendation. And what we have performed then is two distinct simulations, okay, corresponding to the two selected periods of time of the measurement, one in October and one in July, during 1 month. What we could see is that if we take the daylight autonomy performance of each of the period and we do the average value of each of these performance, the results was really close to the annual performance with a very low relative error, as you can see here. So this was based on simulation, but we think it can be a promising approach to process our measurement data to be compared to the level recommendations of the standard. I have to be quite quick because we are running out of time, but what we have performed also is some comparison between our measurement results and the simulations to be sure that it is coherent first. And just one slide and I have finished. What I was saying, coherent, and that it is also a promising approach. So what we could see is that comparing for two workstations and two periods, the measurement and the simulation, first of all, we have coherent results between the daylight autonomy of both of approach. The second observation is that if you are looking at the results, the simulation seems to always overestimate the performance. This is due to a lot of things, especially that in simulations we have some hypotheses and ideally modeling of the space, but we think that the measurements can be quite interesting because it will reflect the light perception of the occupants, and that we can use such approach to evaluate the standard. So at the conclusion, we have presented a setup that allow to assess the lighting performance in a space during a selected period of time. Our question was that can we extrapolate this assessment on these small periods of time to an annual metric, and what is the optimum duration of this measurement? And finally, our perspective, I'm really speed, but we have planned a new measurements campaign in order to increase the statistic to test this protocol and to test the optimum duration of the measurement we have to collect to assess the annual performance on the room. And finally, could we imagine a robust measurement methodology that could assess the daylight quantity performance in the next update of the standard? So what do you think? Thank you.